Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving linear inequalities and graphing the solution on a number line. So you know how to solve linear equations. An equation would have an equal sign here, but an inequality has a different sign, like a less than, greater than, or whatever. So the way you solve linear inequalities is exactly the same as you solve linear equations, but there's one difference. If you multiply or divide each side by a negative number, you need to reverse the inequality. That's the only difference. So why is that? So for example, you know that 5 is greater than 3. That's pretty self-evident. But if you change the sign of each number, -5 and -3, we have to reverse the inequality. 5 is greater than 3, but -5 is less than -3. See, when you multiply or divide each side by a negative, you change the sign of each side. That's why you need to reverse the inequality. So let's look at solving this one here. We're going to solve it as if it was x plus 3 over 5 equals x over 4. So what I'm going to first do is get rid of these fractions to make it a bit easier. So I want to multiply this side of the inequality by 5 to get rid of the fraction. But if I multiply the left-hand side by 5, I must also multiply the right-hand side by 5. So it'd be just 5x over 4. Now, if I want to get rid of this fraction here, I need to multiply this side by 4, so that means I need to also multiply this side by 4. So you can probably see I could have done both of those steps in one by cross-multiplying x plus 3 by 4, x by 5. So now I'm going to expand the brackets. So when we have the pronumeral on both sides, we subtract the one with the lowest coefficient. So I'm going to subtract 4x from both sides. I get 12 is greater than x, which of course means that x is less than 12. So what I've actually found, there are infinitely many numbers I can substitute for x here and here that will make this a true statement. I found that any number less than 12 works. If I substitute x equals 11 in here and here, I will get a true statement. If I substitute x is 0 here and here, I will get a true statement. But if I were to substitute a number greater than or equal to 12, if I substituted, say, x is 15 here and here, it would not be a true statement. So any number less than 12 is a solution to this inequality. So we're going to display that visually on a number line. So I'm just going to put 12 in the middle here. So number lines, of course, go like this. So for x is less than 12, I put a circle at 12 and I point to all the numbers less than 12. So note, if you are not including the number, in this case 12, you have an open circle. If I was including 12, I'd do a shaded circle. All right, let's solve this inequality here. So we can solve it just like as if it were an equation. So first step, I am going to multiply each side by 2. So the next thing I want to do is get rid of the 10 by subtracting 10 from both sides. So now I've got -3x is greater than or equal to 12. I want to undo what's been done to x, so I need to divide by -3. If I divide the left side by -3, I have to divide the right-hand side by -3. So remember what I said, when you divide each side by a negative, you need to reverse the inequality. So my final solution is x is less than or equal to -4. So what that means is if I substitute any number for x that's less than or equal to -4, it will make this a true statement. So how I display that on the number line? Well, I put -4 in the center here. So this time I'm including the value -4, so I shade in the circle, and once again, I'm just going to point to all the numbers less than or equal to -4. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.